Hi, my name is Daniel Liers, and today I present to you guys our semester project with Mr. Alexander Harvey and Cody Nuckles. Here we could see this is our software requirements specification document for our budget and investment tracker. That's the route we decided to go with. Uh, this application is going to be a web-based financial tool designed to help individuals manage their income, expenses, budgets, investments, and financial goals. Um, this document here is going to outline the project's purpose, the intended scope of the application, key terminology, and as well high-level project context. So as we scroll down here, let's just hop into the overall description of the project. So this is going to describe the general capabilities of the system. This application is going to offer seamless income and expense tracking, investment monitoring, and goal setting. Users will be able to categorize their transactions, receive alerts if they pass certain thresholds, and as well view charts and reports of their spending habits. This product will be available on both desktop and mobile browsers with responsive design and as well secure login. Most users are going to be expected to have decent technical skills and as well basic financial knowledge. No training will be needed for the document. However, the system will assume that the user will have basic knowledge of how to use a computer and as well of certain financial data, and they will also be necessary to have stable internet and modern browsers. So here we could see, just going to go briefly, the product perspective, product features. Some key features of the tracker will include income expense tracking like budget creation, investment portfolio monitoring, and data visualization through either charts or reports. Users of the tracker will be able to receive alerts for spending limits and export any financial data. It will also include a secure login to ensure consistent access across certain devices. Going through some requirements here, some functional requirements. It will include user registration and login, transaction entry, budget creation, investment tracking, and goal setting. Users will be able to monitor their progress, receive alerts, and categorize transactions by keyword or merchant. Some non-functional requirements here will be include fast response time, high security using HTTPS and MFA, and an intuitive user interface accessible to all users to make sure that it's going to be easy to understand without training on the software itself. Some external interface requirements. The UI must be responsive across all devices. Communication between front end and back end will use secure HTTPS with RESTful APIs with JSON integration with financial APIs will support data sync for bank and investment accounts. No special hardware will be needed for the application. Some system features. System will allow secure login, financial tracking, budget alerts, return on investment calculations, and personalized financial planning. Users can manage financial data easily, make informed decisions, and track progress towards saving goals. So really the whole purpose of the system here is to track your financial data and make sure you're not overspending, underspending, and making sure that you're spending your money in the right way. Some other just simple requirements here. Compliance with data protection regulations will be required since it's going to be dealing with very high level security data. The app must be accessible to users with certain disabilities and support localization features such as foreign currencies. Resources such as FAQs and tips will support user access. So that's going to be our SRS document here. Going into our software design document, this document describes the technical structure of our tracker and it details the design, decisions, architecture, data models, interfaces, and system components needed to implement the requirements outlined in the SRS. So the system architecture here. So the system follows a client-server architecture. The front end communicates with RESTful Node, JS backend. Key services include authentication, financial data APIs, and notification systems, and the backend is modular, supporting independent scaling of components. Through our detailed design, components include user management, budget management, transaction management, investment tracking, reporting, and notification systems. Each component has well-defined inputs, outputs, and internal data structures. For example, the investment module calculates return on investment using real-time data, while the notification module will send alerts based on threshold. So for the rest of this document, I'm going to hand it off to Mr. Nuckles, and he will be able to explain the rest of the project. Thank you.
Okay, so continuing on with our software design document, we're looking at Section 4, our data design. Our data design ensures both efficiency and integrity. The budget and investment tracker uses a relational database model which organizes data into structured tables such as users, transactions, budgets, investments, and goals. Each user is assigned a unique ID, and their associated records like expenses or savings goals are linked via foreign keys. This guarantees that all financial data is consistently tied to the correct user. In terms of data flow, everything begins on the front end. When a user enters a transaction or edits a budget, that input is sent directly and securely to the backend API. The API processes and validates the data, then stores it in the database. This flow is bidirectional, meaning data also comes back to the UI for real-time display and charts. Additionally, background services may periodically sync investment data from third-party APIs or trigger alerts when users hit budget thresholds. On Section 5, we talk about design constraints. There were a few technical constraints we had to account for during development. The system must be built using a JavaScript-based stack, including React or Vue.js for the front end and Node.js with Express for the back end. All communication must occur over HTTPS with JWT token authentication. Infrastructure is cloud-based, which means performance partly depends on provider limits. Third-party APIs like Plaid have rate limits and security rules we must respect when using them. Our team size required modular, testable design. Section 6, we're talking about security and safety considerations. Security was a top priority during the sensitive nature of user financial data, of course, if we're handling this. Passwords are never stored in plain text, only secure hashes. HTTPS encrypts all front and back end communication. The multi-factor authentication is supported. Regular backups are in place. Third-party APIs use secure connections with validated inputs. Critical actions are logged for auditing. For our design decisions, we had several design choices that shaped our system. Modular front-end / back-end separation supports scaling. RESTful API for predictable communication. Relational database for clean, reliable queries. Interactive charts improve usability and decision-making. Choices align with goals of extensibility and long-term maintainability. So, moving on to our software test document. For our test plan, it follows the IEE 829 standard and verifies all requirements outlined in our SRS. Testing layers include unit testing, integration testing, system testing. We use black box testing for user interactions and some white box testing for internal logic like ROI calculations. And that's what basically we talked about in Section 1. For Section 2, our test design specification, we created 10 test cases labeled here, each with conditions, inputs, expected outcomes, and post conditions, which are all stated here. And each case is mapped to the SRS requirements via traceability matrix. And for Section 3, our test execution report, all 10 test cases that we tested passed successfully. The highlights were the alerts were triggered properly, the reports matched database records, the encryption was confirmed, MFA registration worked, but we did run into some very minor issues. Our duplicate entries when clicking add quickly now fixed, though we fixed them. Inconsistent date formats, which also has been fixed, just as stated here. All in all, for our test summary, all major features worked correctly. The system is secure, reliable, and ready for deployment. Traceability confirmed complete coverage. Further stress testing is recommended, which we will end up doing.